Right, hi everybody. So today we're going to be talking about variation and proportionality. It's a nice, easy class. So let's get started with this very short topic, right? So variation and proportionality. Let's look at this equation here. We could see y is equal to 2x, and we know that for every input x, I should get some output y. Yeah. Now, I have many ways that we could think about this equation. We could think about it like a scale, like how we had marbles in the scale that had to be balanced. We could also think about it like a graph or a line or geometry or shapes or an image or a picture. Yeah. We could also think about it like a mapping or a relationship. And that whole relationship thing is what we're going to focus a little bit more on today. So we could also think of this equation like a proportion. So what do I mean by proportion? Well, let's check it out, right? If we have y is equal to 2x, let's just take a look at the ordered pairs here. And we could see that if x is 1, y is 2 times 1, which is 2. Right? If x is 2, y is 2 times greater, which is 4. If x is 3, y is 2 times greater, which is 6, and so on and so forth. So we could see here that with this relationship, y is always 2 times greater than x. So this is, in a way, a proportion. In terms of the proportion of x and y is always 2 times greater than x, right? So y is always 2 times greater or 2 times bigger than x. So instead of an equal sign, we could use this sign here. It's the sign for proportion, and all that it says is that y is some proportion or proportional to x, right? Now, if we look at the graph of y is equal to 2x, we'll notice something really, really important. And I'd like you to pay close attention to this, right? If we look at the graph, you'll see that as the x values get larger, the y values also get larger. And we could see it from the ordered pairs, this table over here, that as the x values get bigger, the y values also get bigger. Right? So as x increases, y also increases. And this is a super important little fact to remember. Yeah? So if we look at this y being proportional to 2x, we could see that as x increases, y also increases. We could even see this from the graph or from the table. So when you have both x and y increasing at the same time, we say that y is directly proportional to x. So directly proportional means that if one of them increases, the other one will increase as well. So let's take a look at this equation one more time, and we could notice something, that y is totally dependent on x. So whatever the value of y is, that depends on whatever x is. So we could say that the value of y is kind of chained down. It depends on whatever the value of x is. And the value of x could be anything. The value of x is free to be any number. Yeah. So because y is dependent on x, means that we'll call y the dependent variable. And we will call x the independent variable, because x could be anything. X is free to be anything that it wants, but y is always going to be dependent on whatever x is. Now, questions often like to ask you to identify the independent variable from the dependent variable. And we could see here that whatever is the subject of the formula will be a dependent variable. So in this case, y being the subject of the formula is dependent on whatever else is in the formula. Yeah. So y is the dependent variable and x is independent. X could be anything. Yeah. Now let's take a look at this equation. Y is equal to 1 over x, or 1 divided by x. And let's take a look at the table here with the ordered pairs. Now when x is 1, y will be 1 over x, which is 1 over 1, right? When x is 2, y is 1 over 2, which is a half. When x is 3, y is a third. When x is 4, y is a quarter. When x is 5, y is 1/5. So what are you noticing here? You should notice that as the value of x increases or gets bigger, the value of y actually gets smaller and smaller. So we could see here that as x gets larger, y gets smaller, and the bigger that x is, the smaller y will be. So we could even see this on the graph of y is equal to 1 over x. We could see that as the x values get larger, the y values get closer and closer to 0. So as x gets bigger, y gets smaller. Yeah. So we could say here that y is proportional to 1 over x, right? However, when x gets larger, right, y gets smaller. So therefore y, we call it inversely proportional, right? So an inversely proportional relationship is one where when one variable increases, the other variable will actually decrease. When one gets larger, the other one gets smaller. Yeah? So we have these two types of proportions that we have to remember: directly proportional and inversely proportional. Now, when y is directly proportional to x, we use the proportional sign here, right? And now we could, from saying that y is directly proportional to x, we could now form this equation: y is equal to kx, where k is some constant that we don't know. Yeah? We don't know what k is, but k is a constant that makes it an equation. Yeah? Now, in this case, they're being directly proportional, so as x increases, y will also increase. If y is inversely proportional to x, then we could see here that this is how we write it. Y is inversely proportional to x, or y is proportional to 1 over x. And from this, we could form the equation y is equal to k over x, yeah, where k is some constant that we don't know. Also, we could see with an inversely proportional relationship that when x increases or gets bigger, y will decrease or get smaller, yeah? So k now is a constant. We call this the constant of proportion, or the constant of proportionality. And in many, many questions, we are often required to find what is the constant of proportionality. So let's take a look at some of these questions right now. Write down an equation that connects the variables of this table. So we could see here that if we look at the x values, we could see that the x values are actually increasing. And when we look at the y values, we could see that the y values are also increasing. So when x increases, y also increases. So therefore, we could recognize that this is a directly proportional relationship, and therefore y is directly proportional to x. So when we recognize that y is directly proportional to x, we could use the equation y is equal to kx, where k is the constant of proportionality. So now we just have to substitute values for x and y. And we can actually use these ordered pairs. So let's use this first pair when x is 2, y is 6, right? And when x is 2, y is 6, you could see that it is easy to find what k is. K will be 3. And therefore, the final equation that describes this directly proportional relationship would be y is equal to 3x, where 3 is the constant of proportionality, right? Let's take a look at this other example here. And with this example, we could see that as x increases, y actually decreases. So as x gets larger, y gets smaller, right? So from this, we should recognize that this is an inversely proportional relationship, and therefore we will use y is inversely proportional to x, or y is proportional to 1 over x, yeah? 1 over x being the inverse, hence y is inversely proportional to x. So once we've established this, then we could form an equation using our constant of proportionality. Y is equal to k divided by x. And then we could plug in a value, values of x and y. So let's use the first ordered pair there. When x is 2, y is 12. And from this, we could actually get k to be 24. And now we have the equation that describes this inversely proportional relationship. Y is equal to 24 divided by x. So this is a super simple, topic. A nice, easy, tiny little topic that they like to bring every, for every past paper. You'll have a small question on this, yeah? It's a nice, easy marks to get. Now, another thing that they like to do is they like to just give you a graph. And you see in here that the equation for this graph is y is equal to negative 5x. So you look at the equation and you might get fooled into thinking that, well, y is equal to kx, right? But don't get fooled just yet. The question that they're going to ask you is this relationship here, is this graph here, a directly proportional relationship or an inversely proportional relationship? Well, to answer this, let's analyze the graph and see. We could look for the lowest value of x there being minus 2 or negative 2. And for that low value of x, we see that we have a very large value of y. Y will probably be over 8, yeah? And we could also see that as the x values increase, the y values decrease. And so from the graph, we could conclude that this is an inversely proportional relationship. Yeah? Now, they like to bring questions like this where they'll just show you a graph and they'll just ask you to determine whether it's directly or inversely proportional. They also like to bring worded questions, and we all know we love worded questions. Yay. So just remember, when it comes to worded questions, we're going to read the question piece by piece. You don't ever read a worded question, the whole thing one time. No. You read each sentence and try to decide what each sentence is saying. So first we could see that the number of hours required to do a job varies inversely. The number of hours required to do a job varies inversely. So immediately I'm starting to think of hours as being the variable h. We could use h for hours. And if it varies inversely, then I'm picturing in my mind 1 over h. Yeah? So you notice I didn't even read the rest of the question yet, and already I'm drawing certain conclusions based on the information that I'm getting. So I have 1 over h in my mind. Let's read further, right? So the number of hours required to do a job, h, varies inversely, 1 over h, right, as the number of people working. So let's call the number of people P. So I could kind of form a relationship here, and I could say that P is inversely proportional to H, right? Because the number of hours required to do the job varies inversely to the number of people. Now you could see here that it takes 8 hours, so they gave us a value of H, for 4 people, so they gave us a value of P. Okay, we'll look at that, right? So from this proportion, P is inversely proportional to H, I could form my equation, P is equal to K over H, where K is the constant of proportionality. Yeah? And you see here that they gave me a value for H, which is 8 hours, and they gave me a value for P, 4 people. So I'll just plug those values into my equation, and I'll find for K, and K is 4 times 8, which is 32. So now I have this final equation here, P is equal to 32 over H. And from this equation, I could find anything else that they ask me for. You notice I still didn't read out the rest of the question yet. And look at all of the information that I got so far. Yeah? So it takes 8 hours for 4 people to paint inside of the house. And we saw that from that information, I could have gotten this equation. P is equal to 32 over H. Now we're going to read the question. How long would it take for 5 people to do the job? Well, that's pretty easy. I have a value 5, and I'll plug that in for P, and I have 32. So how long is H? How many hours, right? So it's just a matter of substituting. 5 people is equal to 32 over H. 5H is equal to 32. Therefore, H is equal to 32 divided by 5, and the answer to this being 6.4 hours. So believe it or not, that's basically it for variation and proportion. We took a look at the constant of proportionality, K. We also took a look at the 2 different types of proportions, being directly proportional and inversely proportional. And also remember the types of variables, the dependent variable and the independent variable. So these things are super important, and as I say, they often bring a question for this in CSEC. So what I would ask you all to do is to do this entire worksheet for me, please. And I will see you for the next lesson.